Alright, so we're going to draw a parabola. Here's our equation. Y equals x squared plus 2x plus 3. And we're going to use the method of analysing the coefficients. So the first thing we want to know is it an uppie or a downy? And we do that by looking at the a value. So let's just be really clear what we have here. So we have x squared plus 2x plus 3. And of course, there's an invisible 1 there. So that's the a value, that's the b value, that's the c value. So the a value is positive, which is telling us, so a is greater than 0, so therefore we have an uppie. Right, write down the value of the y-intercept. Now, if you know what we're doing, we can just look at it straight away and say the value of the y-intercept is y equals 3. But let's be clear what that means. That means we're asking what is the y value when we put 0 into the function. So let's put 0 into the function and we get 0 squared is 0 plus 2 times 0. That's why it's 3. So the y-intercept is the 0, 3 value. Now we're going to use this lovely formula. X equals minus b on 2a, which you will just burn into your memory, is the axis of symmetry. And hopefully you remember some of the reasons why. But for now, let's just use that formula. So x is minus, so the b value is 2 on 2 lots of the a value. I think it's really good to write it like that. So it is negative 1. So now we know where the axis of symmetry is, which means we can find the vertex. So again, to find the vertex, we take our function, and our function is to do this. And we're going to put the axis of symmetry location in. So that's going to give us 1. Oops, that should be minus 1. Subtract 2 plus 3, which is 2. Therefore, the axis of symmetry is a negative 1, 2. Let's do now a look at the discriminant. So the discriminant is b squared subtract 4ac. So the b value is 2. I think it's really good to write it out like this. Just put the values in, that way we're not going to make errors. So it's 4 subtract 4 times 3. Ooh, we can immediately see, I'm not even going to bother calculating it, it's less than 0. So that means when I use the quadratic formula to find the roots, let's remind ourselves of the quadratic formula, I'm in trouble. I'm in trouble because this doesn't work, it's negative. So there are no roots. That's why it has no intercepts. And now we know absolutely everything we want to make the graph. Let's make the graph x, y. Okay, so what were we? Axis of symmetry is minus 1. Draw the axis of symmetry, just plop a minus 1 there. Not worrying about the y scale. I'm just going to put a 2. There it is, 2. Okay, now I'm going to worry about the scale. The y-intercept is at 3, so I better get that scale. If that's 2 units, that's 3 units. And, ooh, that's looking good. And that's all the information we've got so far. Clearly has no roots. And the final thing it says, use symmetry to locate another point. Now it's an interesting question, why do we want another point? Because right now we have 1, 2 points on the parabola. Strictly speaking, we'd like to see 3 to lock it down. So we're just going to use symmetry. So that means there's another 3 point here. What's it going to be? Well, that's 1 unit. So that's 1 unit. So this point is negative 2, 3. And that's my nice curve. Let's just check that. I've got one ready that I made earlier in GeoGebra, and indeed that is exactly the right curve. And that's the standard technique for drawing the curve using the axis of symmetry.